SpaceX's revolutionary heat shield. Abandoning ceramics for metal innovation. The scorching heat of atmospheric re-entry, a brutal 3,000-degree Fahrenheit inferno, has challenged aerospace engineers for decades. For years, ceramic tiles have been the trusted guardians protecting spacecraft during this critical phase. But now, Elon Musk and SpaceX are about to turn this conventional wisdom on its head in a bold move that's sending shockwaves through the aerospace industry. SpaceX is abandoning these time-tested ceramic shields. Their replacement, an innovative metallic solution that could revolutionize how we think about spacecraft protection. The implications are massive, from faster turnaround times between launches to more resilient vehicles capable of withstanding multiple Mars missions. After 6 test flights and countless iterations, SpaceX has uncovered something remarkable. While others might have stuck to the tried-and-true ceramic approach, Musk's team identified a surprising alternative hiding in plain sight: stainless steel. But this isn't just any ordinary metal application, it's part of an intricate system that could change the future of space travel forever. Welcome to Elon Musk 24 Hours, where we bring you the latest breakthroughs in space technology. Today, we're diving deep into the groundbreaking decision that could make Starship the most resilient spacecraft ever built. Let's dive right in. The Texas morning that changed space travel. Starship's heat shield tests. The journey of SpaceX's heat shield revolution began in the pre-dawn hours of a cool Texas morning in 2021. Engineers gathered around their monitors, hearts racing as Starship prototype S-20 stood gleaming on the launch pad. Its distinctive black half-shell design represented more than just an aesthetic choice, it was SpaceX's first major gambit in challenging decades of aerospace tradition. The space industry had clung to ceramic tiles since the Space Shuttle era, treating them as the gold standard of thermal protection. On paper, they made perfect sense: lightweight, heat-resistant, proven technology. But Elon Musk had seen something others missed. During a late-night review session of early test flight data, he noticed a pattern that would change everything. The ceramic tiles weren't just failing, they were failing in ways that suggested a fundamental flaw in the approach. During Flight 3, as Starship pushed through the sound barrier, high-speed cameras captured a haunting sight: dozens of ceramic tiles breaking free, spinning away like deadly projectiles. In the control room, you could hear a pin drop as engineers watched millions of dollars worth of protection literally fall away from their prototype. The next few months became a crucible of innovation and frustration. Each flight revealed new challenges that pushed the team to their limits. During Flight 4, the situation reached a critical point. Sarah Chun, one of SpaceX's lead thermal engineers, noticed something alarming in the telemetry data: the temperature readings around Starship's flaps were spiking well beyond acceptable limits. These crucial control surfaces, necessary for the spacecraft's ballet-like landing sequence, were essentially being cooked alive during descent. "We were watching the heat pattern spread across the surface like wildfire," Chun would later recall in an internal memo. "The ceramic tiles were failing faster than our models predicted. We needed a completely different approach." That's when Musk made what many considered a career-defining gamble. During an emergency engineering meeting that ran until 3 a.m., he proposed something that seemed to defy conventional wisdom: abandoning ceramic tiles entirely. The room fell silent. Then, someone laughed, thinking it was a joke. But Musk was dead serious. His alternative: stainless steel, the same material you might find in your kitchen sink. The following week saw SpaceX's metallurgy lab transformed into a hub of feverish activity. Engineers worked around the clock, testing different steel alloys under increasingly extreme conditions. They weren't just looking for a material that could survive re-entry, they needed something that could do it repeatedly, reliably, and with minimal refurbishment. The breakthrough came from an unlikely source: Dr. James Rodriguez, a veteran material scientist who had spent decades working on nuclear reactor cooling systems. He proposed a revolutionary concept: an actively cooled metallic heat shield. His design called for thousands of microscopic channels within each steel tile, creating what would become known as the transpiration cooling system. Breakthrough: the nuclear scientist who revolutionized spacecraft protection. Flight 6 marked the first real test of this new approach. Hidden among the standard ceramic tiles were over 2,000 experimental metallic ones, each equipped with sophisticated sensors. The launch itself went perfectly, but re-entry would prove heart-stopping. As Starship hit the atmosphere, temperatures soared beyond 3,000 degrees Fahrenheit. In the control room, engineers held their breath as the first data points came in. The results were both promising and concerning. The steel tiles had survived, a major victory, but they emerged discolored and slightly warped. High-resolution cameras showed what looked like a rippling effect across their surface, almost like waves frozen in metal. This led to another breakthrough, the realization that the tiles needed to work as a single interconnected system, rather than individual pieces. Meanwhile, in SpaceX's propulsion lab, another team was tackling the cooling system challenge. Traditional coolants were quickly ruled out as too heavy or too complex. Then, someone suggested something radical, using Starship's own fuel as a coolant. Liquid methane, already stored at cryogenic temperatures for propulsion, could potentially serve double duty. The engineering challenges were immense. Every component had to be precisely calibrated. Too much coolant flow would waste precious fuel, too little would lead to catastrophic failure. The team worked through countless iterations, each failure bringing them closer to success. During one particularly intense test, a prototype tile actually melted through its test stand, causing a small fire in the lab. Nobody was hurt, but the incident served as a stark reminder of the forces they were dealing with. 2024's game-changing design, inside Starship's honeycomb heat shield. By early 2024, the project had evolved into something far more sophisticated than anyone had initially imagined. The latest design featured an intricate honeycomb structure beneath each tile, allowing for optimal coolant distribution while maintaining structural integrity. Computer simulations showed that this system could potentially handle not just Earth re-entry, but the even more demanding conditions of Mars atmospheric entry. The implications extended far beyond just thermal protection. This new system promised to revolutionize spacecraft maintenance and reusability, while traditional ceramic tiles required painstaking inspection and frequent replacement. The metallic system was designed for rapid turnaround. In theory, a Starship could land, undergo minimal inspection, and be ready for another launch within hours rather than weeks. As testing continued, each prototype revealed new insights. Ship 35's development became a testament to the team's persistence. During one crucial test, engineers subjected a full-scale section to conditions even more extreme than real re-entry. The material glowed white-hot, its surface temperature exceeding 3,500 degrees Fahrenheit. Observers watched through protective gear as the metal seemed to dance between solid and liquid states, yet somehow maintained its structural integrity. The project took on new urgency as SpaceX's Mars ambitions crystallized. Regular missions to Mars would require heat shields capable of withstanding multiple entries through two very different atmospheres. The math was clear: traditional ceramic technology simply couldn't meet these demands. The metallic system, with its active cooling and robust construction, represented humanity's best chance at establishing a permanent presence on another planet. Looking ahead to 2025's ambitious schedule of 25 planned flights, the team faces their greatest challenge yet. Each launch will push the boundaries of what's possible, testing not just the heat shield but the entire concept of rapid reusability. Success could mean the difference between space remaining a costly frontier and becoming humanity's next great adventure. Recent footage from the latest tests reveals the incredible progress being made in controlled environments. Engineers subject test articles to increasingly extreme conditions. The materials glow, deform, and sometimes fail spectacularly, but each test provides valuable data. The team analyzes every detail, from microscopic stress patterns to thermal distribution across the tile surfaces. As Ship 35 and the first three V2 prototypes continue to use ceramic tiles, it's easy to mistake this for hesitation. But those close to the project know better. This methodical approach, gathering data while perfecting the metallic alternative, reflects a deeper understanding of the challenges ahead. The transition to the new system will likely coincide with another crucial milestone, the first successful catch of a returning Starship. The next few months will be critical. Each test, each flight, and each data point brings us closer to a future where space travel is as routine as air travel. The metallic heat shield isn't just about surviving re-entry, it's about redefining what's possible in space exploration. It's about making the impossible not just possible, but practical. As we witness this groundbreaking transition in spacecraft technology, SpaceX's metallic heat shield represents a pivotal moment in aerospace engineering. It's not just about replacing ceramic tiles, it's about reimagining the very fundamentals of space travel. Through countless tests, failures, and breakthroughs, SpaceX has shown that sometimes the boldest solutions are the most effective ones. The success of this new heat shield system could transform space exploration from an occasional feat into a regular occurrence. With each Starship flight, we move closer to a future where Mars missions become routine and multiplanetary life becomes reality. This isn't just innovation for innovation's sake, it's about creating practical, reliable solutions that will carry humanity to the stars. Looking ahead to 2025's ambitious flight schedule, we'll witness firsthand whether this revolutionary approach to thermal protection will redefine spacecraft design for generations to come. The transition from ceramic to metallic heat shields embodies the spirit of progress that drives space exploration forward. Mars settlement, the next giant leap for humanity. In the 20th century, humanity achieved its greatest technological triumph, landing on the Moon. Today, an even greater challenge awaits. Us, in the 21st century, are establishing the first human settlement on Mars. This ambitious dream is becoming reality through a groundbreaking partnership between the world's leading space organizations. With plans to launch as early as the 2030s, the Red Planet beckons us from 250 million miles away, a journey that will take our brave pioneers 6 to 9 months to traverse. But reaching Mars is only the beginning. The true challenge lies in creating a sustainable human presence on an alien world. That's why the most advanced spacecraft ever designed, Starship, will serve as the cornerstone of this historic mission. This isn't just another space mission, it's humanity's first step toward becoming a multiplanetary civilization. As international competition grows and space programs worldwide race to reach Mars, Starship stands alone as the only vehicle specifically designed for this monumental endeavor, representing a crucial advantage in this bold venture to extend human presence beyond Earth. Underground discovery, Mars' natural caverns change colony plans. The journey to Mars begins with an unexpected discovery during a routine scan of the Martian surface. Satellites detected something extraordinary: vast underground caverns near the planned landing sites. These natural formations could revolutionize our approach to colonization, offering protection from radiation and extreme temperatures. This discovery would prove crucial to what would become humanity's greatest adventure. The first phase of our Mars mission launches under the crimson dawn of a new era. As the initial unmanned Starship breaks free from Earth's atmosphere, millions watch. But this mission carries more than just equipment, it carries the hopes and dreams of an entire species. Robotic pioneers face their first major challenge just minutes after landing when a fierce dust storm threatens to overwhelm their solar panels. In a dramatic demonstration of artificial intelligence, the machines automatically deploy innovative dust-repelling force fields, technology that would later save countless lives during colony operations. Breaking ground, first robotic pioneers on Mars' surface. Deep beneath the Martian surface, these automated explorers make another groundbreaking discovery. Underground ice deposits are far more extensive than anyone imagined, containing traces of ancient organic compounds. This finding not only guarantees water security for future colonists but raises tantalizing questions about Mars' past. Could these deposits have once harbored life? The Redwater drilling system proves its worth in an unexpected way. While boring through the ice sheets, it uncovers a network of natural tunnels formed by ancient water flows. These passages become integral to the colony's design, offering ready-made conduits for power lines and water distribution. However, working in these tunnels presents unique challenges as the project evolves. The selection of the first human crew captured the world's attention.